Hello, good afternoon, everyone. Am I audible? If my voice is clear, you can just give me a heads up in the chat, then we'll start. Uh, yeah, I think there's a lag in the chat, so could you all just please confirm once, then we can start? Okay, okay, perfect. Okay, let's start. Good afternoon, everyone, and welcome to the kickoff session for the Summer Projects 2026. I hope you all are excited because over the next few weeks, you won't be just learning tools, you'll be learning how real business problems are. And for those who are joining us for the first time, we are the Consulting and Analytics Club of IIT Guwahati, a community that impacts more than 1 lakh students annually through multiple international initiatives. I am Prakhar Gupta and I'll be serving as the overall coordinator of this club and the host for the session. A little about me, I am also a contributor of the Viksit Assam project under the initiative of Viksit Bharat 2047, which is led by Prime Minister of India, and also an associate product manager at Student Web Community of IIT Guwahati. So, before we begin, I want to clarify one thing about these projects. These are not just typical college assignments where the objective is to just submit code. Uh, they are they are real business problems. So these projects are designed to stimulate real industry problems and the kind of problems companies actually hire analysts and consultants for. So throughout the program, your goal should be to understand a business problem, work with messy and incomplete data sets, extract meaningful insights, and finally recommend decisions that create impact. Also, we will also be rolling out the certificate for participants who certificate of completion for the participants who successfully complete the project requirements, and more importantly, the submission link will be rolled out on a registered email. So let's get started. So the first project, which is the digital lending, will be led by me, and I'll be explaining about how this you should approach for this particular project, and then I will invite my colleagues uh, further to further present the rest of the projects. So the first thing that comes in our mind is ki what exactly is digital lending. So digital lending, like there are many banks that give out loans, right? But also, uh, let's say ki imagine you need 50,000 rupees urgently. So instead of going to a bank that takes weeks and tons of paperwork, you open an app, fill a form, and get money into your account in just like 10 minutes. So that's digital lending. Companies like Credby, MoneyTap, or say Zest Money do exactly like this. So these companies give loans to people who buy, let's say, phone on EMIs, which is basically buy now pay later. Small shopkeepers needing working capital and salaried people needing personal loans. So let me just clarify what the actual problem that comes here is. So these companies give out thousands of loans every day, and some people repay on time, some people are late, and some other people that never repay. So this particular thing is called a default. A company like these have tons of data: who borrowed, how much, when they paid, what their income was, and etc. relevant things, but they are not using this data smartly. uh, it's like having a treasure map but not knowing how to actually read that. So what essentially you have to answer in this particular problem statement is key: which customers are risky, provide early warning signals, best loan products, let's say, or if is there any other pricing strategy that you can come up with. Also in this particular problem statement, we have in the last we have also mentioned key questions to address. So this is a particular thing that is for you to navigate through the problem statement. You could like read all these questions and understand what actually you have to add in your presentation in the report. So you don't have to state these 5 questions like as a heading and then answer all these questions. These are just for your understanding, so you can get a brief idea on how you can approach these problem statements. So first of all, on top of every problem statement, that is data. Without data, there is no solution to any problem statement. So first of all, let's discuss something about the data sets that you will require here for making this credit worthiness policy. So in this particular problem statement, you have to create a data set, or there are many data sets that could be available on Kaggle, let's say, and UIC machine learning repositories, and also there is a lending club open data set from where you can find all these loan data sets that you can use to analyze the actual credit worthiness. Also, I would like to state one thing over here is, which is that you please don't consider these data sets as very static data sets, or you just find one data set and you build your approach on top of it. A particular real world solution derives from many KPIs and indexes. So it's not necessary that you find one data set and build your approach on top of it. There are many other indexes that you will need to take in consideration in order to build your strategy on top of everything. So this is really a very sensitive thing of detecting credit worthiness among people. So you need some really hard numbers to deliver your solution in that gap. So when you will find all these data sets, you curate them, you clean them, do the feature engineering, and what you will have to do is first extract insights from all the data sets, and there will surely some gaps that you will notice ki, okay, if this particular metric or this particular factor is increased, so I think the chances of this person being a loan defaulter is more. So these are the gaps that you have to analyze from that data set, and you have to build your policy on top of these gaps. So your main goal is only to identify these gaps in the data set, in the KPIs, matrices, everything that you will find online, all the research reports, all the data sets, and you have to then build your approach on top of these gaps. Also, you should have one thing in the end, that your end goal is not to build a very complex model. The end goal is to deliver a real actionable solution. So focus more on feasibility of the solution rather than you have just built a ML complex ML model with 94 or some sort of accuracy. So this was it from my side for the first problem statement. Now I will invite my colleagues for presenting other problem statements, and we'll be discussing all the curated doubts at the end of this presentation of all 4 problem statements. So hi Achyut, now I would like to invite my colleague Achyut to present the second solution.
Yeah, Professor, am I audible?
Yeah, you are definitely audible. You can start.
Okay, so let me present my screen. My presentation is visible, right, I believe?
Yes, Achyut, it's visible.
Okay, going on to the project number 2. So let us start with a scenario. Yeah. Imagine you run a fashion brand. You sell clothing, footwear, accessories. Everything is direct to customer. No stores, no middleman. Just you and your customers online. And business is good. You almost have 4,000 customers. You run discount campaigns. People keep buying. And here's the thing: you start to wonder: are these people really loyal to my brand, or are they just showing up for a sale? Because there's a massive difference between a customer who comes back every month, regardless of whether there's a discount, and a customer who only shows up when you give them 30% off. One of those customer builds your business, the other one slowly bleeds your margins. And right now, this brand has no way to tell the difference. They have the data, but they have zero intelligence built on top of it. This is what exactly the problem statement is asking you to fix. So the brand has 5 core questions they cannot currently answer. Question 1: who are generally loyal customers versus who only buy when there is a discount? What behavioral patterns today will predict which customers stay and keep buying over time? Which locations in the US are commercially untapped, places where brand has real traction but has has never deliberately invested? How should the brand restructure its promotional strategy to protect margins without losing volumes? And question number 5, what does the brand's best customer actually look like so that we can go find more of them? So yeah, and the challenge in this problem is that the data set gives you none any doesn't give you any kind of shortcuts you might hope for. So there is no loyalty score column, there is no churn level, there are no timestamps telling you when someone first bought or when they last bought. So you cannot just run a standard model and be done with it. You have to build your understanding of loyalty from scratch using the signals you have. So coming on to the data set, this data set has 3,900 customers, one row per customer and 18 columns. So here is something that might surprise you. The brief actually requires you to build not one but two different definitions of loyalty and then compare them and choose the better one. Why? Because loyalty is not one thing. Depending on how you define it, you get different answers and different customer segments. Let me give you a simple example to make this concrete. So imagine two customers, okay? Customer A and customer B. So customer A has 45 previous purchases and customer B also has 45 previous purchases. So customer A spent $90 on their last order and never used a promo code. Customer B also spent $90 but always used the promo code. Under a simple how much have they spent and how long have they been around definition of loyalty, these two customers have been identical. Both seem loyal. But customer B has never once proved that they will pay the full price. Remove the discount and what can happen? The customer B might disappear. Customer A will stay regardless. So which customer is actually loyal? It depends on your definition. That's the analytical challenge. This brief asks you to build one definition based on value. How long someone has been around, how much they spend, how satisfied they are. And the second definition based on behavior. How frequently they buy, how long have they been around, and critically whether they need a discount to buy at all. You score every customer under both systems, then you compare and you argue clearly for which definition is more useful for this business. And here's the thing, there is no single right answer. What matters is your reason. If you can explain clearly why you have chosen this definition of loyalty and why this better captures what the brand actually cares about, that is a strong foundation. So then moving on to our deliverables. So deliverable number 1 is a clean dataset and with engineered features. So this is your Python output. You load raw dataset, fix the data quality issues like we talked about before. Like there are some data quality issues like the missing ratings, the frequency level inconsistency, and then you build new columns that capture the insights you need. This is feature engineering. So, for example, you would create a column called tenure score based on previous purchases, or you would create a frequency score based on how often they buy. So then maybe you can combine these two to make your loyalty scores. So this is how you do feature engineering. Then coming to SQL segmentation analysis, once you have your cleaned enriched dataset, you load it into SQL. You can use something like SQLite or even run SQL inside of Python, and you write queries that answer the 5 business questions, which I have mentioned before. So, after this, the best way to write these queries is using CTs. So CTs is common table expressions, which basically means you break your logic into clearly named step. It is cleaner, easier to read, and looks far more professional. And the deliverable number 3 is a Power BI dashboard. This is a visual layer. The Power BI dashboard is used for someone who is not a data person, a founder, a marketing lead, or a business partner. So here you need to make four panels. Panel 1, a customer pyramid showing how value is distributed across the customer base. Panel 2, a chart showing which customer group depends on discounts and whether those are the same groups that stick around. Panel 3, a geographic map of the US showing which states have a genuine brand pool versus discount inflated volume. Panel 4, category funnel showing which product categories attract newer customers versus which ones are associated with long-standing loyal buyers. Each panel should answer one question in probably under like a minute or under if the founder or anyone who doesn't know about data is looking into it. So next one is the deliverable for the retention playbook. So this must have 2 parts. Part 1 is the promotional sunset plan, which means you identify specific customer segments, explain which ones would lose discounts first, explain what triggers that decision, lay out the timeout for rolling it out, and name a metric you will watch to know if it's working. Part 2 is the ideal customer profile. You describe using actual data what the brand's ideal customer looks like. And the last one is the executive summary. This is a maximum one-page document, not a full report, just the three most important findings, what they mean for the business, and the important actions. This, okay, that's it. Over to Dhairya.
Okay, thank you so much, Achut, for the presentation. I hope that all of you now have a clear idea of what and how how the project is gonna structure gonna be. So now I would like to invite my colleague there to start the presentation of our airline loyalty program problem statement.
Hello everyone. So today I'll be explaining the problem statement unlocking behavioral intelligence in airline loyalty programs. So before understanding the technical side of the problem, let's first understand what the actual business problem is. Airlines today have huge loyalty programs where customers collect points, redeem rewards, and receive benefits for flying frequently. The goal of these programs is to increase customer retention and improve customer lifetime value. But the issue is that most airlines still use a very reactive system. They mostly focus on points and rewards instead of actually understanding what customer behavior is. Because of this, many customers slowly become inactive without the airline noticing early enough. Some customers stop flying regularly, some stop redeeming points, some remain enrolled in the loyalty program but are effectively disengaged. So, the real challenge is not lack of data. Airlines already have a lot of customer data. The challenge is converting that data into meaningful, actionable insights. In this problem statement, we act as a business analyst team of a mid-sized airline. We are given the data of around 16,700 Canadian local members from 2012 to 2018, and our job is to help the airline identify customers likely to disengage, understand which customers are truly valuable, and recommend strategies to improve retention. Now, this entire problem statement can be divided into three major objectives. The first objective is churn prediction. Now, normally when we hear churn, we think of customers formally canceling their membership. But in this dataset, churn is broader than that. A customer might technically be part of the loyalty program, but may stop flying frequently or stop using points entirely. So, one of the first things teams need to do is define what churn actually means. And there is no single correct answer here. Teams are expected to create their own logical definitions and justify it properly. Another very important challenge is to prevent data leakage. This basically means while predicting future churn, the model only uses information that would realistically be available at that point of time and not any future information. The second objective is customer segmentation and customer value analysis. The airline already tracks customer lifetime value or CLV, but the problem statement specifically asks us to go beyond just revenue numbers. The main question becomes, what actually makes a customer valuable to an airline? Is it flight frequency? Is it its loyalty tier? Is it its seasonal consistency? Or is it the redemption behavior? So, teams are expected to create meaningful customer segments, not just statistically different groups, but segments that actually help the marketing team take actions. For example, some segments could be high frequency business travelers, seasonal travelers, high spending customers at risk of churn, or customers who are heavily dependent on rewards. The third objective is smart retention. This is where the project actually becomes very business oriented. The problem statement clearly mentions that vague recommendations are not enough. Recommendations should clearly mention who receives the intervention, when they receive it, why that intervention makes sense, and what form it should take. For example, instead of saying give discounts to customers, a stronger recommendation would be offer premium value upgrades to high frequency business travelers who have shown a sudden drop in activity over the last few months. Now, let's talk about the dataset. The dataset consists of 4 integrated files. The first file is customer loyalty history, which contains demographic information, loyalty tiers, CLV, and cancellation records. The second file is customer flight activity, which contains monthly flight bookings, distance traveled, and points earned or redeemed. The third file is calendar dataset, which maps dates into months, quarters, and seasons. Finally, there is a data dictionary, which explains all the columns in the dataset. An important thing mentioned in the problem statement is that this is a realistic data set. It contains anomalies, contains inconsistencies, and edge cases. So teams are expected not only to build models, but also to make smart analytical decisions during cleaning and pre-processing. So, moving forward, let's discuss how someone should approach this problem. The first step should always be understanding and cleaning the data. Teams should check for missing values, inconsistent records, anomalies, and understand how customer behavior changes.
Hello guys, I think there was some issue with the network. I think we are back and we'll start with the next presentation anytime soon. Hello Nalan, am I audible?
Hello, yes, Prakhar, you are audible. Should I start?
Just a second, Nalan. Just let me adjust some things here. Yeah, Nalan. Hi. You can start now. I think we are back. I'm really sorry for the any inconvenience that was caused here.
That's okay. So I can start, right?
Yes, Nalan. Go ahead.
Okay. So let's start with a simple question. Have you ever ordered something online? The app says it will arrive by 6 p.m. and it shows up at 10 p.m. That's really annoying for you as a customer, right? Now imagine that happening at the scale of crores of packages every single day across India. That's exactly the problem Delivery is facing. Delivery is India's largest logistic company. They have warehouses, delivery hubs, and routes connecting every major city and town. To predict delivery times, they use a tool called OSRM. Basically, think of it like Google Maps for trucks. It calculates the fastest route and gives you an estimate time. But here's the problem. OSRM assumes perfect conditions. No traffic, no delays at warehouses, no seasonal rush. Real life is nothing like that. And when you actually look at the dataset we have provided, which has nearly 1.5 lakh real delivery trips, you will find that in 95% of trips, the actual time was more than 20% higher than the OSRM predicted. On average, packages took more than double the predicted time. Some trips took 77 times longer than predicted. So the big question this problem statement is asking is, can we build something smarter? Now let me explain what participants are expected to build in simple terms. The key idea is this. Instead of looking at each delivery route in isolation, treat the entire logistic network as a map. Every warehouse and hub is a dot on that map. Every route between two hubs is a line connecting those two dots. This is what we call a graph in computer science. You must have heard about that. So once you build that graph, you can start asking really interesting questions. Which hub are so important that almost every package passes through them? Those are very potential bottlenecks. If one of those hubs gets congested or slow, it delays hundreds of routes downstream. So the first task is to build this graph from that data and then use graph math to find the top 3 most problematic hubs, the ones causing the most delays across the network. The second task is to build a prediction model. First, to build a basic prediction model, just using simple trick information like distance and route type to predict delivery time. Then you build a smarter model that also uses the graph structure, the position of a hub in the network, how connected it is, how congested its neighbors are. And you have to prove with numbers that the graph model is better. Not just claim, prove it. The third task is to figure out when to use FTL versus carting. FTL means a full dedicated truck going directly from point A to point B. Carting means smaller shared vehicles that may stop at multiple places. When you look at the dataset we have provided, you will see that carting trips are on an average 2.4 times slower than predicted, while FTL trips are about 2 times slower. So there's a trade-off. Participants need to build a framework that helps delivery decide which option to use for which kind of route. Yeah. And finally, this is the most important thing that you have to do. You have to write a strategy memo, not a technical report, not a list of model metrics. A memo written for business leader who does not know what MAE or graph SAGE means. It should say, here are the top 5 problem hubs. Here's what you should do about each one, and here's how much improvement you can expect if you fix the top 3. Yes. So now I will be telling you that how can you approach it from the start. So basically, you should start by cleaning the data. There are some missing values and weird outliers that need to be handled and documented. Then build the graph using a Python library such as NetworkX. Then compute the graph metrics to find the bottleneck hubs. Then build the baseline model, then the graph enhanced model. Compare them and finally write the memo. When you open the dataset we have provided, you will see all the ingredients are there. Actual delivery time, predicting time, facility codes, route types, etc. The factor column is the most important one. It is simply actual time divided by predicted time. A factor of 1 means perfect prediction. The average in the dataset is 2.12, meaning packages take more than double what was predicted on average. So your goal should be to reduce the factor. Okay. So coming to deliverables, there are 5 major deliverables and an optional deliverable also as a bonus. So the first deliverable being clean, well-documented code of the entire pipeline that you have made. Okay. And secondly, a visual map of the logistic network with the bad hubs and delayed corridor highlighted. Thirdly, a model comparison table, baseline versus graph model, showing improvement in predicted accuracy. Fourthly, the FTL versus carting decision framework with numbers backing it up. So we also need the numbers, not just the theory behind it. Okay. And fifth, the strategy memo. And that is the most important one. It should be of 1 to 2 pages ideally, written for an operation leader, naming specific hubs and specific interventions. And there is also an optional deliverable, which is a live streamed dashboard showing the network with real-time delay risk scores. That's a bonus, so you can try that also if you want. So wrapping it up, the problem is a combination of machine learning, graph theory, and business consulting. It's based on delivery data. It solves a real operational problem, and the final output is something a real operation head at delivery could actually read and act on tomorrow. The resource folder attached to this problem has everything you need to understand. The graph ML techniques, graph SAG, and node to wake. Before you start coding, use them, they'll make the technical side much clearer. So yes, that is about problem statement 4. Happy to take any questions if there are any.
Uh, right. I have been informed that during my presentation in between the stream was closed, so we'll continue back from where I had stopped. Basically, I was explaining the data set at that time, so I'll start from there. The data set consists. This is for the third problem statement. Um, I'll start again. The dataset consists of 4 integrated files. The first file is customer loyalty history, which contains the demographic information, loyalty tier, CLV, and cancellation records. The second file is customer flight activity, which contains monthly flight bookings, distance traveled, points earned or redeemed. The third file is the calendar dataset, which maps dates into months, quarters, and seasons. And finally, there is a data dictionary which explains all the columns in the dataset. And an important thing that I would like to mention in this problem statement that has been mentioned in this problem statement is that this is a realistic dataset It contains anomalies, inconsistencies, edge cases, and such other, and so on and so forth. So teams are expected not only to build the model but also to make smart analytical decisions during the cleaning and processing. Now, let's discuss on how a person would approach this problem. The first step would be to always the first step would always be to understand and clean the data. The team should check for missing values, inconsistent records, anomalies, and understand how the customer behavior changes over time. The second step is defining churning properly. Before building any model, the team should clearly decide what qualifies as a churn. For example, it could be no flights for 6 months, no point activity, no formal cancellations, and so on. A strong submission would not just define churn randomly, but also explain why that definition makes business sense. The third step is feature engineering, as explained earlier by Achyut also. The feature engineering would help capture the behavior patterns that the raw data alone cannot directly show. The fourth step is customer segmentation. The teams can use clustering, behavioral segmentation, or even rule based approaches to divide the customers into meaningful groups. But again, I would like to stress on the fact that the focus should not be just on statistical separation, and the segment should also be useful for business decisions. The fifth step is to build the churn prediction model. Teams can use models such as logistic regression, random forests, or XGBoost. But the project is not only about achieving a high accuracy. The model should also be interpretable and useful from a business perspective. Finally, comes the business recommendation section. This is where the teams would convert the analytical insights into real actions. For example, personalized retention campaigns, tier specific engagement strategies, premium customer recovery plans, and so on. Now, I would like to talk about what makes an exceptional submission. An exceptional submission is not necessarily the one with the most complicated machine learning model. Instead, the strongest submission would combine its analytical rigor with strong business thinking. Some important things that an evaluator might likely look at and likely think of is of value is a clear logical churn definition, meaningful and actionable customer segments, proper handling of data leakage, strong storytelling and communication, and a highly specific business recommendation. Another major factor is the prototype or dashboard. The problem statement specifically mentions that the interface should be easily usable by a non-technical marketing manager without guidance. A good dashboard should immediately help the manager understand where the customers are at risk, why they are at risk, and what actions should be taken. Finally, coming to the deliverables. There are two main deliverables. First is a working prototype which can be built using tools like Streamlit, Power BI, Tableau, Excel, and similar uh, other similar softwares. And the second deliverable is a technical report, which should be around 6 to 8 pages. This report should explain the problem framing, cleaning decisions, segmentation logic, model choices, key findings, and business recommendation. And very importantly, the report should be written for business stakeholders, not for an academic research. To conclude, this problem statement is not just about analytics or machine learning. It is really about understanding customer behavior deeply enough to help a business make smarter decisions. The strongest solutions will combine good analytical thinking, business understanding, clear storytelling, and actionable recommendations. We have also attached the dataset, data dictionary, and additional resources for the problem statement. So I would highly recommend everyone to go through them carefully before starting the project. Now we can move forward with the doubts section.
Uh, Hello everyone. So thank you so much there and all my colleagues for the presentation. Now let me just one time summarize that what all happened here. Then we can move to the doubts discussion. And also I would like to state some of the important points. The first point is that the deadline for submission for all these projects is 15th of June. Uh, that is next month, the 15th of next month. And also I would also like to state that please, every one of you, please join the WhatsApp community for the further details that will be shared, and the link to the WhatsApp community is below in the group. And if you are not able to share your doubts here, and if you are watching the recording of this live stream, you're always encouraged to ask your doubts in the community, or as well as in the respective groups of the problem statements. So to summarize what all happened, all of my colleagues along with me explained all the 4 problem statements, what are we expecting from you, and what is it to be like a very valuable solution. So on top of it, I would like to state that every solution you build should be on top of data. The data is the primary thing that you should focus on, and build your strategies on top of all these data. So yes, data is the key, data is the treasure, and yes, you should really work on research plus data and integrate that into your solution. Because just a vague solution, if I say okay, I think some people are defaulters, some people will repay, I think that's a really very vague statement. So every statement you make in your solution, I think that should be based on top of any numbers, any indexes, any research reports that you find online. So that was it from my side. Now I think we can move to the doubt section. So yeah, just a second. So hello guys, now I would request you to all please open your videos. I think then we can get to the doubt section. In the audience as well, I would now request everyone to please drop their doubts, and I'll see and let them know to the panel, so you can ask them. Also, I request everyone to please add a problem statement number along with your doubt, so that we can get a reference of what problem statement you are asking. So in the comment section, I can see there is a doubt by Kirthi. So I would like to present the one of the doubts that we have. For the ETA analysis, what factors do we know about when it comes to building the better ETA predictability?
Could you please tell again? Sorry.
Yeah, sure. There is a doubt from Kirthi. For the ETA analysis, uh, what factors do we know about when it comes to building the better ETA predictability?
Yeah, so we have also given in the dataset the congestion and all that is there in the warehouses, right? So while predicting the ETA, you need to see the congestion in the nearby warehouses as well as the congestion at the warehouse that is at from where the delivery is going. So yeah.
Okay, I think that answers. Also, we have one another doubt. Is it only the traffic and connectivity of the hubs, or also other factors like different routes, seasonal surges, traffic density, etc.?
Sorry.
Okay, let me just repeat. Is it only the traffic and connectivity of the hubs, or other factors like different routes, seasonal surges, traffic density, etc.?
So the traffic density and the seasonal searches should also be taken care of, like, other than congestion.
Okay, perfect. I am also expecting. Are we expecting some other doubts in the section, in the chat? guys, you are free to ask any questions. Just please give the reference also to the problem statement you are asking of. We have one more doubt here. uh, I would like to, in the optimizing ETAPS, it is given that we need to identify and prior hub upgrades. What does that exactly mean?
Yes. So, sorry again. I was unable to hear your question clearly. Can you please repeat it?
Yeah, that's totally fine. Let me repeat the question. In the optimizing ETAPS, it is given that we need to identify and prioritize hub upgrades. What does that exactly mean?
Yes. So, regarding the pyro warehouses, so yes, you need to identify the pyro hub upgrades, right? Uh, so you are basically uh,
Okay, that's fine. I think there's some issue with Nalan's network. No worries. We'll get back to that question. In the meantime, let's move on to the next question. The next question is, in digital lending, how do we handle customers with no formal credit history? So I think that's a really good question. So I would like to answer that. So see, whatever the approaches you built, whether it is an ML model or anything like that, so there is a very high possibility that a particular customer is not having any formal credit history. So that's where your solution come into place. So I have like already stated that you have to search for data sets and then build a strategy to identify the credit worthiness of a particular person. So if a person with no formal credit history comes to you and asks for a loan, you will have to apply all your policy frameworks to that particular person in order to identify whether this particular question is credit worthy or not. I think that answers your answer. That answers the question. Sorry. Okay, I think we now have a very general question, and I would like to present it to the panel. So the question that is, what kind of presentations earlier stood out more than others? Was it more cleaner documentation, actionable decisions, or better presentability, or something else as well in particular? So I think that's a really very general question, and I would like to open this question to the panel. So yeah, on to you.
Honestly speaking, it would be a mix of all of these. Like, we do definitely prefer some clean documentation and actionable decisions. And better presentability helps the person in front of you understand what you are trying to say better. So it's a mix of all of them, honestly.
Am I audible?
Yes, you are.
Okay. So the sort of submissions we are expecting is something that has made an impact. So something as simple as presenting how much impact your solution has made is something we're looking forward to. That's a small addition to the point.
That's great. And on top of this, I would like to add something else. Since you asked what were the presentations that actually stood out, so if a very clear answer to that would be a proper structure. In the first slide, you have to present what the actual problem is and what are the things that you see. If you are presenting this to a recruiter, most probably the recruiters will mostly be searching for three things. First, the structure of your thinking. Second, the numbers in your presentation, numbers as in the kind of reports you analyzed and keep up with metrics and KPIs. And the third would be the number of frameworks that you have used. So in the whole presentation, I think a key important part is using frameworks, because if you are in front of a recruiter, I think you should tell him that yeah, I know these frameworks, I know how to use numbers. So I think these are three are the key things that you should definitely include in your presentation. Yeah, so I think we have another question here in the chat. So in the question I would like to state in front of the panel. So the question is, in decoding customer value, it is mentioned that the brand has no physical stores, but in the data set for some customers, the shipping type is mentioned as store pickup. What does this mean exactly?
So, see, that is maybe up to the.
If you don't mind, Achut, I would like to answer this question. So basically, this is, as we have mentioned, there are a lot of inconsistencies in the data. There can be multiple reasons for this, since as we mentioned, this is a real world data set. So we want you to we want you to think of this as a misinterpretation in the data set, document this, and to mention how you are what steps you are taking to correct that.
Definitely, I would
Yeah,
also
justify
suggest.
your analytical decisions over there.
Yeah, I would definitely go with his answer, because the real thing is that in real world data sets, you do not get 100% accurate databases. You get some of the issues in the real world data sets. You cannot expect 100% pure clean data sets. So that is some of the noise that you will have to eliminate, as well as if you see that particular noise in a very large percentage, you should take that into consideration, document it, and find possible reasons why this went wrong. Uh, okay. Uh, I think we can close the session now. And also, I would like to state to all of the participants that have joined us, thank you so much for joining. And also, if there are any further doubts, you can always approach to any of the mentors that the contacts have been given in the problem statement. And also, you can join the WhatsApp community as well. Also, and at last, I genuinely hope that by the end of the session you now have more clarity, not just about like problem statements, but about how to think like an analyst, consultant, or strategist while approaching them. And also, I would like to state those golden words again, like every approach solution you deliver here should be built on top of data. Data is the only thing that you should look on, and keep in mind those three factors while making a presentation. The first is your strategic thinking, second is numbers, and the third is using frameworks in your presentation. So also, before we wrap up, I request you all to join the WhatsApp community using the link given below. All further updates regarding the deadlines or any updates and announcements will be shared there. And you can also use the groups to post doubts, discuss ideas, peers, and stay connected throughout the project. And this, more importantly, the submission link will be conveyed to you on your registered email ID, which you use to register for summer projects. So yeah, on behalf of everyone, on behalf of the consulting and analyst club, thank you everyone once again, and all the very best for your summer projects. Thank you so much for joining.